Hello everyone, my name is Leon Yuan and today I'll be presenting a workshop on the introduction to Python. So first we have to talk about installation of Python. So you can download Python at python.org/downloads. I would suggest getting the most recent version of it, which would be Python 3.9.2, which is found by the link below, or found by the link there. And you can pick the version that matches your architecture and operating system. So if you're using Windows and if you're 64-bit, then that would be the choice for you. A quick distinction is that Python 2 is not Python 3. So this is very important, and code that works in Python 2 doesn't necessarily work in Python 3 and vice versa. What we'll be using today is the PyCharm IDE. If you don't have an IDE already ready, I would suggest using this. It's very easy to use. You just need to download it and open it up, and a lot of the features will be there. So you can get this at jetbrains.com and look for PyCharm. So before we begin talking about the language of Python, I wanted to talk about what makes Python so prevalent in our modern society. So the first thing is Python is very unique. It's very versatile in that it can be used in scripting, it can be used for software development, it could be used for your full stack, it could be used for your machine learning algorithms as well. And it's easier to learn compared to other language, but despite being easy to learn, it has a lot of depth. This comes from the multiple libraries that you can import and use along the way. So some companies that use Python are Instagram, Quora, Reddit, Dropbox, and Google. This is more on the software development side. However, most companies use Python as their main machine learning language, as there's a lot of support for machine learning in Python. So on the software development side, Flask, Django, Selenium, Beautiful Soup, as well as some scripting is very powerful in creating your own web application or just setting up a backend. And for machine learning, there's Keras, PyTorch, TensorFlow, NumPy, Pandas, SciPy, Spacey, as well as NLTK. And this really is what Python is known for, is all of its machine learning support. So for this hackathon, you could try out some different projects. It's up to you to decide which one you want to do. I split the categories into machine learning / data science and game / software development. So for data science, you could find a data set, dissect it to see what you can learn from it, what trends are there, and then maybe you could play around with. So for the hackathon, there are some possible projects that you can try out. I split the categories between machine learning / data science and game / software development. So what you could do for machine learning is find a data set, dissect it to see what you can learn from it, what trends are there, maybe pull in some other data sets so that you can mix and mingle to find out different trends based off 2 different data sets. It all depends on how much time you have left. Or you could try making a neural network that learns to play tic-tac-toe or some other game. On the game / software development side, you can make a game using Pygame to create Flappy Bird or Tetris or some sort of game that you want to mimic. And then you could also try making a web app using Flask or Django. So maybe a cooking recipe website, a calendar, or a to-do app. It's all up to you. Now we'll be moving on to talking about Python basics. So in Python, we have variables. Variables keep track of values and it can be used also to keep track of objects. Ways to declare it can be using a value, using another variable, or using an expression of a combination of the two. In Python, we should try to understand some of the data types that our variables could fall into. So our variables could be an int. This stands for integers, for they must be whole numbers. So for example, 1000. Or they could be a float. Floats are decimals. So one case would be 3.14. A string, these are a sequence of characters that are surrounded by double quotes or single quotes. Booleans, these are true-false values. And then if you want to transition between different data types, you could cast it by using this, by using the data type and then surrounding it by parentheses. And so this is a way to cast your variables into a different type. Now we'll be moving on to talking about some of the operators in Python. In Python, there's adding, subtracting, multiplying, dividing, exponentiation, modulus, floor division, and these are the main arithmetic operators. So adding can be done by using plus equals or just a plus. Plus equals is equivalent to this line below. Int num equals int num plus 1. And so the first one would yield 1001 if our int num started at 1000, and our second one would be 1002 after incrementing it again. Subtracting is the same way. You could use minus equals or just the minus by itself. These are the same. These are the same thing, and this applies for all arithmetic statements, as well as concatenation, which we'll learn a little bit later. Now we'll be talking about multiplying, dividing. So these are ways to do operations. Multiplying is using the asterisk, and it can be using times equals. Dividing is different from other languages in that it returns a float. So if I divide my number by 3, it'll return a float rather than it being a whole number. Exponents, you use 2 asterisks, and this allows you to do exponentiation. Modulus, this, if you don't know what modulus is, it's the remainder of when you divide something by another. So if 10,000 modulus 3 would just be the 1 left over. And then there's floor division, which is dividing by the number and then truncating anything after the decimal point. And these all can be done with the operator and then the equal sign, as well as just within some code. Moving on to string operators, there's the concatenation. So if I start with a string of hello and another string of world, and I add them together or concatenate them together, they become hello world. And that's how you would be able to do concatenation. There's also Boolean operators. So in Boolean, you could use equals, greater than or equal to, greater than, not equal, less than or equal to, and less than. And these come out to be used mainly with numbers, but you can also use equals with strings. Another thing in Python is you can chain your Boolean operators. So I could do 1 is less than equal to my variable x, which is less than or equal to 3. And this is a lot easier in Python compared to other languages, because in other languages you would need two different operators, but also you would need to use an AND as well. Now I'll be talking about ways to combine your Boolean operators using AND, ORs, and NOTs. So you could use, if you use AND, you require two Booleans. So in this case, we have true and false. The only case where when you use AND, it'll be true is where you have true on both sides. So this is the only case where you would have true for AND. Any other case, such as true and false, false and true, false and false, will yield false. For OR, it just requires one of the two to be true. That's what OR means. So true or false is true, but the only case where it is false or false. Then it's false. Not is different from AND and OR. Not is simply for negating the current Boolean value from true to false, or if you're currently false, you switch to true. And lists, now we'll be moving on to lists. Lists are a good way to keep track of multiple items. So you can have 1, 2, 3, 4, 5 and continue adding on to it. But contrary to regular counting, it starts at 0. So all of the lists in Python are 0 indexed. And now I'll be talking about some matrices. If you combine a list and put more lists in it, that becomes a matrix. In a matrix, you can access each specific list by only declaring one access. So if I use 0, it'll give me 1, 2, 3. But if I go out of bounds, then it'll throw me an error. Another thing in Python is you can give it a negative number. So in this case, -1. And it'll give me the last element in this list, which in our case is the list 10, 11, 12. In this case, we cannot use -5. Why? So this would be -1, -2, -3, -4, and -5 is out of bounds. So just keep that in mind if you're ever trying to use negatives. And if you want to access specific elements, you can use 2 accesses. So this gives us matrix var 0, which is this list, and from this list I can pick 0, which is 1 right here. Or I could go to the last list, so matrix var -1, which is 10, 11, 12, find the first element, which is 10, and that's my answer there. Or I could use matrix var -1, -1, and that just means the last element in the matrix, or the last list in the matrix, and then the last element in that list, which is 12. Another concept that you should know is slicing. Slicing allows you to make smaller subarrays of your bigger subarray. So I can utilize this by so how slicing works is it's start, the end, plus 1, and then the step. So basically, if I want to start at 0, I would be passing 0. If I want to end at index 1, which is this one, I will need to put 2. And if I want to move through it one by one, then I would need 1 there. That is how slicing works. So if I had 0 to 1 instead of 0 to 2, I would have 1 comma 2, which is the same as using this. And so in Python, the default values of slicing is the start being equal to 0, the end being the length of the list, and the step being 1. And these are how in Python how slicing works. Another data structure you can use is dictionaries. Dictionaries are similar to lists in that they can help you store multiple information, but in order to access them, they're a little different. You don't need a specific number, but rather a key. This key can be of any type. It can be a string. It can be an int. As long as there's a key for a value, you can always access it. For example, if we use dict_var, or the dictionary variable, and we try to access the presenter key, it'll return Leon. But if I try to access the rowdy hacks key, it'll return error. So if you want to get around this, you could always use a get, and this second parameter will just be the default value instead of throwing you an error. Moving on to control structures. So this will allow you to make your code go in separate paths. So maybe I want to execute some code only if something matches some criteria. So we'll be using, for example, so if the dictionary variable presenter is not equal to Leon, then we'll do this. Print hi I am Leon. However, it is equal to Leon, so we skip executing hi I am Leon and we move on to the else if, or the elif. In the elif, we check if the dictionary variable of audience is you, and it is, so it would end up printing hello audience. However, if this was false, then it would print out none of them matched. So it's kind of a way so that if this works, then I would skip all of these two. But if this doesn't work, I will need to check this. And if it does work, I will need to print hello audience. And if this doesn't work, then I'm going to say none of them matched. Another control structure that you can use is the while statements. So while statements just need a Boolean expression or a Boolean here. And so in our case, we're using loop variable. So while statements can be used to do loops. And so basically what happens is we enter the while loop, we check if loop variable is less than 16. Nope, right now it's 0. Or right now it is 0, so it is less than 16. And we continually add to it until we hit 16, and then it falls out of this loop. For statements. For allows you to iterate using an index without having to create another variable like how it is in while statements. So you can do for I in the range of 10, and this will go from 0 to 10. Or this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all the different values that you would be getting. We'll explain why you get this later. And then lastly, a way to help you structure your code is having functions. So why would you need functions? The main reason why you want functions is that you don't want to reuse code. You'll see in the demo that there's functions that would be very nice if they were separated out. So an example function would be where you define it, the name of the function, all the arguments passed to it, and then if you ever need to return anything, you return like that. There's also built-in functions that will help you understand the demo more. So print will also help you understand Python a little bit more. Print allows you to print directly into system out. What it does is it just showcases the string that you pass into it. So it'll just show hello world. Range actually so we used range in our for statement up here, and I didn't really explain it, but basically what it does is it's similar to splicing, where it takes the start, the n+1, and the step. And so that's how we create our list over here, which is this range. And similar to slices is that there's default values of 0 and the start, and a default value of 1 in the step, but there's no default value of where it ends. And so that's something you must define. So in our case, up here, it's our end is 10. Our n+1 is 10, so it ends at 9. In the case down here, it ends at 6. And then there's the length function. This basically just lets us know how long is a list, how many elements are in it. So in this list, there's 5 elements. And then we can move on to max. It just returns the max value of all the different arguments passed to it. So 1, 2, or 3. 3 is the biggest out of all of these. And then min is the minimum of these numbers. It could be more than 3. It has to be at 2, at least 2, but it can be as long as you want it to be. So 1, 2, 3, and this would be 1. In your program, you might need to import other modules. How you would do so is by importing the module name and then using it from there. There's definitely other ways to import, but if you're new to importing, feel free to reach out to mentors. But the main way would be to import random or import the module name, and in this case I use random, which is what I'll be using in my demo. So you could use random, and you can use all of the different functions that they made it. Now we'll be talking about our demo. Today we'll be coding up Connect 4 as our demo. And some things to understand before we start getting into it is that we'll be turning the board to make it a lot easier to code. But it will require rotating it back when printing. We'll be using zero index lists. So there's a row 0 and column 0, and it won't be using all the topics that we covered in the basics of Python portion. We'll be splitting it into some smaller subproblems though, and this will make it a lot easier to solve. So the subproblems are: 1, checking for a win. So we'll be checking for a row, a column, a diagonal, and the other diagonal. Another subproblem that would make it a lot easier is check if given in a list 4 in a row are the same element, and adding a new piece in, and then iterating until someone wins. Just to clarify what I mean by the first diagonal and the second diagonal, as you can see in the image, there is one diagonal going to the bottom right, from the top left to the bottom right, but there's a different one that goes from the bottom left to the top right, and these all need to be taken into consideration. So let's hop right in. So if you go into PyCharm, you might get some code looking similar to this. It may have a print statement here, but let's go ahead and get started. For today's coding demo, we'll need the random module, and let's start with creating our board first. So for our board, we'll be adding in 7 different rows. So board.append a new row, and for each row we will be using a space to indicate that it's empty. But because we're using these spaces, it's hard to tell where the current marker is at. So we'll also be using a separate list in order to hold all of the different how many markers have been dropped into each row. So lengths. And so now we have our board prepared. We will be creating a way to print our board. And so let's go ahead and do that first. So print board. And if we print, we'll be using, I believe, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And we want to be iterating through from the column side. So column range 5 to -1, and then going backwards. So this just means that we'll be starting at 5 and going all the way till we hit 1 or hit 0, because it will not count this -1, and then we want it to decrease negative by -1 each time. Line equals to a bar, and for the row, range of the length of the board, line plus equals to board of the row and column plus the bar again. Then we can print out the line, and then we can print out the ending portion, which will be this, and then we can print one more time. And so if we go ahead and print the board, we should have something ready. So as you can see, here is the board. It may be one off. But it showcases our board that we'll be using. Right now we haven't added any markers in. So we will not be notating any of that. Next, let's consider adding our markers in. So we're going to make another function, call it add marker, the player, and the row they want to add to. So the reason we want to use each of these vertical lines as a row is because it's a lot easier to manage, because of the gravity effect, where all of the pieces must be going downwards. So in order to add our marker, we first need to find out what our current column is that we're adding to. So our current column is based off our row lengths that we created earlier to keep track of every row. And we can use it with row and always increment our row lengths. So this just helps us keep track of what column we're in when we next access it. But what is the current column? The current column is the row, and we want to change the board. The board of the row plus the current column is our new value, which is the player. So in our case, we'll be making the player one character. So in our case, it'll be R and Y. And then if we want to, but here's the thing, each row cannot have more than 6, and so if we add to a row that has more than 6, there's going to be something wrong. So we can return a Boolean to just let the function that called it know whether or not it added it in successfully. So you can return true here, but then we also need to check to see if the current row length is already 6. So that helps us keep track of adding markers. So now if I add a marker of red to row 4, and then we print the board again, we should be able to get something. Run it. And so as you can see, it's currently in row 4. besides adding the marker, we also want to be able to continuously add it. And so this is where random comes in. And so we'll be using a count variable to keep track of the turns, or turn variable. Turn is 1, and we'll be using a while true just to have it keep going on forever. But then we also need to find a way to continue adding. For the purpose of the demo, I will be using random numbers. So random.randint just gives a number from 0 to 6 in our case. So if the turn mod 2 equals to 1, this just means if it's odd, so if it's the first player's turn, then we want to add the marker. However, it won't always add the marker, and so we need, while not add marker, lock equals to a new number from 0 to 6. It won't be the most efficient way to do this, but it'll be a way to ensure that there's no shenanigans where one player goes twice. And the same thing for the else, for the other player. So I'm changing the for to lock, or the location, which we can change the variable name real quick. Location, and change the location again if there's any chance that it'll repeat, because if we're adding the marker and if it's false, then we want it to keep going. But if it's true, we just want it to skip past. Then we want to increment the turn by 1, and we can always print board. But before we run it, we want to check if there's a win of the current location. So why not just check the win of the whole board? Well, you can make use of the information that they're adding pieces in one by one, and so you just need to check whether the last piece they added has created a win for one of the players. However, check win is a lot more complicated in that we have to handle the 4 different subproblems, so a row, a column, the diagonal 1, and diagonal 2. So check win. So for now, we'll defer that to a different function. So the column, so if we give the row, column is now the row lengths, -1, row, -1. And we can defer this to all the different functions. So if check row of row col, or if the column has something, or if the first diagonal has something, or if the last diagonal has something. So these are all the different cases that we need to consider, and this will help us out in trying to solve this problem. So return false. Keep in mind that any functions I need to access are on top of the current function, mainly because it needs a way to access it, and if it's not before it, then it can't find it in the program. So let's start with check row. So check row, row column. So for our check row, we want to consider all the points. So for our example, the points would be each of these markers. So we want to check if all these points for a certain row match up to the same thing. So if board row max of 0 to column -3 all the way to the column +1. So in terms of slicing, why am I using max? Well, I don't want it to go to negative below 0, so I can use max so that it caps it off between 0 and the column -3. Now, why is it col +1? It has to reach the end of the row, but still include row column. And if it were to be just col, or just a column, then it would not include our current column. So we need to make this col +1. So these are all the different points we're checking. So what we are going to do is implement a way to check all of these points to see if there's 4 identical elements next to each other. And so this just needs a list of points. Okay. And we'll be going through all the points. Point index and the range of the length of points -3. So the main reason I just do the -3 is to ensure that the size of the points left over when we do our slice will always have 4. So our group of 4 is then able to be found with a single slice. So if I use point index, I can use the point index +4, and this will always give me a slice of 4 consecutive points that is being passed in. Now we want to check if it's connected, and so we can use a flag here in order to keep track of whether they're all the same or not. So for point in the group of 4, so this will iterate through all these lists, and the point will be each element in this group of 4. So if point is not equal to the first element, basically all of the elements need to be the same, so we're just using the first one just to make it easy on ourselves. But we also need to check it's not our starting variable, so we're just going to do that. So if it's, and in these cases we want to make our flag be false, which just tells us that these points are not connected. And so by the end of this, if we know it is connected, we can just return true. But we have to check all the different points. And so if we haven't checked all the points, we can, or if we've already checked all the points, then we can return false if it hasn't found it. But after looking through the whole list of groups of 4s, if there's none that's connected, it'll return false. So with that, we can just return check 4 of all of our points and proceed to do the same thing with column, diagonal, and check, and diagonal too. So let's go ahead and do that. So we can make all of our function prototypes here. So we have all of our function prototypes. There we go. So different from how we did the row, we'll be adding in elements into our another list rather than using the original list or original matrix. And so we can use another variable. We can use the same concept of using max to set a minimum number that it can go to. So if we do max of 0 minus row minus 3, and then set a max of, or set a ceiling of what it can go through to. So in our case it's 7 because we want to be able to go to 6, and 7 just means 7 is a limit, so it can't hit 7 and it will be ending at 6. And so we can go ahead and add these points into our points array, and we can return check 4. So we're checking for 4 in a row in our points. So that's the first one done. Points equals list. So same thing. For diagonal, we're doing the same thing for new row index. Max 0 row minus 3 with the min of being 7 and row plus 3. However, we want to be able to calculate the offset for the column, and so in our diagonal one, the offset of the row is the same as the offset as the column. So new row index minus the old row is our offset, and our new column index is equal to the column plus the offset. And so now we can add the new position in. Just to be safe and check if it's in bounds, we can use a Boolean statement here. So equal to 5, and we could do points.append toward new row index and the new column index, and we can return the check for 4 in a row of all these points. Now we have one more to go. So points equals to a list for new row index. So these are very similar. So the two different diagonals. The only difference is how you use the offset. So the offset for diagonal 2 will be subtracted instead of being added. So if you look at it, new column index is the column minus the offset. So that's the only difference between these two. And we can go ahead and copy the rest. And our check diagonal 2 is good to go. And if we run it, just to be sure, I can print out what my final turn is. Final turn is the location, comma, the other, the row lengths of the location minus 1. And we can also when adding the marker, print out where we're adding to. Print row current column, and if we run it again, you can see that the game is complete. So we start from adding red, yellow, red, yellow, red, yellow, red, and it keeps going until it finds a win, which is 4-2, which if you see, it's this diagonal right here. So what it comes down to for this hackathon is trying to take it and solve it in a way where there's a lot of different problems to solve. So Connect 4 itself is not a hard game to understand, but in order for it to be a lot more easily interpreted, what you can do is you can create smaller subproblems. And here are some of the small things that you can continue adding afterward. Of course, some of these aren't small, but here's, for a hackathon like this, what you should do is start small and keep adding to it. So you could add a score tracking system, so like keep track of who won the most games if there's multiple games going on. You could even add like some sort of artificial intelligence, maybe have it think a certain depth further, or add machine learning if that's what you want to do. Something more difficult would be online multiplayer, or using machine learning, of course. Or you could just make this into a graphical user interface using some other modules. So these are some of the ways you can improve a small demo like this. And thank you for watching.